Every serious robotics lab in the world is fighting over the same scarce resource, and it's not compute. It's behavioral data, the recorded signal of a body moving through a physical environment, making decisions, failing, adjusting, and succeeding. That data is hard to get. You need a robot, a trained operator, a physical space, and enough hours to build a distribution wide enough to generalize. And even then, you've mostly taught your robot to do the things you set up the demo for. This week, a company called General Intuition announced it's in talks to raise $300 million at roughly a $2 billion valuation. If you read the coverage, you probably came away thinking, okay, another robotics funding round. But the funding announcement is honestly the least interesting part of this story. The interesting part is what they're claiming is their training data, roughly 2 billion gaming clips per year, captured through a platform called Metal. And their thesis is that this library of humans playing video games in first person is a better foundation for teaching robots physical reasoning than any robot telemetry dataset that exists. That's a bold claim. I think it's worth sitting with for a few minutes because if they're even partially right, it changes how you think about where the embodied AI race actually gets decided. So let's actually think about what a world model for a robot needs to learn. At minimum, it needs 3 things. It needs causal structure. If I push this object off this surface, it falls. It needs action-consequence chains. If I reach this way and grip here, the object moves predictably. And it needs spatial coherence under uncertainty. The world continues to exist and behave consistently even when parts of it are outside my field of view. Those are not trivial things to learn. They require seeing a lot of examples of agents making choices and watching what happens next, at a frame-by-frame level in a physically consistent environment. Now think about how robot telemetry tries to teach this. You deploy a robot, you record what its sensors see, you record its motor commands, and you label outcomes. The data is high fidelity in the sense that it's real physics, but it's expensive. The OpenX embodiment dataset, which represents a serious multi-institution effort to aggregate robot experience, covers a relatively limited set of tasks and embodiments when you compare the total data volume to the scale of, say, a language pre-training corpus. You simply cannot generate robot telemetry at the speed and scale you can generate text or images, because every data point requires a physical robot to exist in physical time. And critically, a robot operating in a controlled research environment is not exploring a very wide distribution of physical situations. It's mostly doing versions of the things you built the lab to demonstrate. Here's why gaming footage looks interesting as an alternative. A first-person game is, at its core, a physics simulation with a human providing dense behavioral labels in real time. Every frame encodes an agent's eye view of a three-dimensional environment. Every controller input is a structured action annotation. And the human playing is constantly exercising the exact capacities that robot policies need. Navigating around obstacles, estimating distances under partial occlusion, picking up and manipulating objects, recovering from unexpected failure states. All of that is happening continuously, at scale, and the data is already being captured because people want to share their gameplay. The marginal cost of the training signal is, from General Intuition's perspective, essentially zero. This is where Metal comes in concretely, and it's worth being specific about what the platform actually is. Metal captures gameplay clips, the kind players record to share highlights, from a wide range of games across a long accumulation period. The figure General Intuition is working with is roughly 2 billion clips per year. These aren't passive screen recordings. They're first-person perspectives of humans solving spatial and mechanical problems, usually under time pressure, with controller input data that effectively timestamps every intentional action the player takes. Think about what that looks like as training data. You have a first-person view of a three-dimensional rendered environment, depth cues, parallax, object permanence, physics. You have a human making continuous decisions about where to navigate, what to pick up, how to aim, how to manage distance and angle. And because many of these games are action games or survival games, you have constant examples of the player encountering unexpected situations and adapting, which is precisely the hard problem for robot generalization. The clip format also gives you temporal coherence. These aren't isolated frames, they're sequences, and sequences are what policy learning actually needs to understand cause and effect across time. Now compare that to the best robot telemetry datasets. The OpenX Embodiment project, as an example, aggregates data across many robot platforms and research groups, and it's genuinely impressive in terms of the breadth of embodiments represented. but the sheer data volume at the frame level is not comparable to 2 billion clips of human behavioral data. And robot telemetry doesn't naturally give you the wide, weird, unpredictable distribution of situations that generalizable policies need, because robots and research labs are not usually getting into unexpected situations, because the whole point is to control the environment. Metal's corpus has the opposite property. It's humans getting into unexpected situations constantly, because that's what makes a good clip worth sharing. The research grounding for why simulation-derived behavioral data can transfer to physical systems comes partly from work on generalist agent architectures. The argument that if you train on a sufficiently diverse mixture of embodied tasks, the underlying representations start to capture something about physical reasoning that isn't specific to any one body or environment. General Intuition's bet is that gaming footage is the largest and densest version of that diverse mixture that currently exists. Okay, so here's the part I think deserves honest attention, because the counter-argument is not trivial. The core objection is what researchers call the sim-to-real transfer gap, and it's not a solved problem. Game engines are not physics simulators in the robotics sense. They're rendering engines optimized for visual plausibility and responsive feel, not for accurate simulation of contact mechanics, friction, deformation, or the thousand small ways that physical objects behave unexpectedly when a real gripper touches them. A robot policy trained purely on gaming footage has learned a model of rendered physics, and rendered physics is wrong in specific, systematic ways. Objects in games don't flex, fluids don't slosh correctly, and the haptic feedback loop that a human hand relies on constantly is completely absent. There's a meaningful body of research on domain randomization, which is the technique of varying physics parameters during simulation training to build policies that are robust to the sim-to-real gap. And the finding there is that synthetic training data tends to work best when the underlying physics is at least approximately accurate. Metal's game engines pass a lot of tests, but they weren't built to that standard. The risk that the optimists are underweighting is the possibility that a policy trained on 2 billion gaming clips becomes very good at navigating game-like environments and quite brittle in an actual kitchen or warehouse, because the distributional shift from rendered to physical isn't just about visuals, it's about the causal model of how the world responds to contact. So where does that leave us? I think the honest read is that general intuition is probably right about the data being valuable, and the transfer gap question is genuinely open in a way that's interesting rather than dismissive. Here's why I don't think the counter kills the thesis. The argument for gaming footage was never that it replaces physics-accurate simulation or real telemetry for fine-tuning. The argument is that it provides the behavioral foundation, the dense pre-training signal that teaches a model the structure of goal-directed action in three-dimensional space before you ever bring in expensive physical data. If you think of it as a pre-training corpus rather than a complete training pipeline, the physics fidelity objection becomes a lot softer. You pre-train on 2 billion clips of human behavioral intent, then fine-tune with sim-to-real correction layers or a smaller amount of real telemetry. The question becomes whether behavioral density in pre-training beats behavioral fidelity, and that's an empirical question that the field hasn't fully answered yet. What I find compelling is the moat argument. If this approach works even partially, Metal's corpus becomes one of the most defensible data assets in physical AI. Not because of anything general intuition builds, but because you cannot go back and capture 10 years of human gameplay at that scale from scratch. The data has been accumulating. Competitors can collect robot telemetry. They can run their own simulations, but they cannot replicate a historical record of billions of humans solving spatial problems in rendered environments across a decade. That's the asymmetry that makes this more than a funding story. The thing I'd watch for if I were tracking this space is what General Intuition publishes about transfer results, specifically whether behavioral pre-training on gaming data measurably reduces the amount of real telemetry needed to reach a given performance threshold on physical tasks. That's the empirical test of their thesis, and it's also the test of something bigger, whether behavioral density in pre-training is a general principle or a gamble that happens to fit games. And if you're sitting on any large corpus of humans doing goal-directed tasks in simulation, whether that's a VR platform, a surgical training system, or a game publisher's back catalog, this story is worth reading carefully. You may be holding infrastructure that nobody has priced correctly yet. That's your evening context. See you tomorrow.